Just kidding. Okay, so today we're going to talk about proving or verifying identities, which is where you get to work with only one side to make it look like the other. Okay? We're still going to have some common denominator stuff and all that good stuff. Warm up for today. These are the questions we did not get to yesterday. Is there something you would like me to do off 1B? We did not get to these, so I thought we could do a couple for warm up. 14? Okay. It says rewrite as an expression that does not involve a fraction for this number 14 down here. Any ideas how you want to start? Can I ask a question? Is secant squared minus tangent squared something good? These aren't squared right now, but can you look on your reference sheet? It's 1. So what would we multiply this by to get rid of this denominator? Remember, I briefly talked about this yesterday. The conjugate of the denominator. What is the conjugate of the denominator? Secant of x plus tangent of x, okay? All right, so on the top, I'm just going to leave it the mess we get for a minute. But on the bottom, if we FOIL this together, we get secant squared of x, and then we get a minus secant tan plus secant tan, which will cancel out, right? Is everybody okay with that? And then we get a minus tangent squared of x. And you just told me that this is equivalent to 1. So did we manage to get rid of the fraction in the denominator? I mean, we managed to get rid of the denominator, at least temporarily, right? Okay, so now we got to figure out what to do with this top. It no longer involves a fraction, but I still think that might simplify a little bit. I think they're going to ask you to simplify that a little bit more. This is probably the kind of question that I would do as a proof. Like, I would give you what I wanted you to get to. But, so we have this mess. Okay. What should I do? You want me to distribute? Okay, so it'll say cotangent x times secant of x plus cotangent of x times tangent of x. And it's all over 1, so we don't have a fraction anymore. Cotangent times tangent, those are reciprocals. So without even writing out another step, I should know that that's just 1, right? All right, maybe this one we should see if we can do anything. What's cotangent? Cosine over sine. And secant is 1 over cosine. So the cosines cancel and we get 1 over sine plus 1. Now, that still involves a fraction, right? The directions were no fraction, so what could we change that to? Cosecant of x plus 1. Now, is that a Pythagorean identity we should look about trading for? It doesn't have a squared, right? No squared, so we can't trade anything. We're just done. But if I were in calculus, I could differentiate maybe that much easier than this disaster that we started with, right? Okay. Somebody said there was another one they wanted me to do for a warm-up. Was it this one? 12?
12, yeah.
Okay. 12 is one I would not ask you on a quiz because I told you those aren't on the pink sheet. Okay. But does anybody remember, this is like a 90 minus x. The co-function of the complement. Do you remember me trying to talk about that yesterday? Trying be the operative word. If you have the cosecant of 70 degrees, it's equal to the secant of the complement. Okay? So this is the cosine of the complement is equal to the other one. What's the co-function? Yeah, this is sine. Okay. I don't even have a slide that shows the notes from that yesterday, I don't think. So, like I said, not something I would ask you on a test or quiz. What do we have then if we have sine over cosecant? That means we have sine divided by, what is cosecant? 1 over sine. And then back here there's a plus cosine squared. What is sine divided by 1 over sine going to become? Everybody good? I'm ignoring this and making my work go down here. When you flip this over and multiply by the reciprocal, you get, this becomes a sine squared, right? And a sine squared plus a cosine squared will simplify to, so that big disaster was 1. Okay. I'm not saying I wouldn't give you one in a quiz that simplified to 1. That'd be a beautiful thing. But I'm not going to give you one that has cosine pi over 2 minus x, okay? Enough warm up, or someone got a question still? Something stuck on? All right, let's talk about verifying. To verify an identity means to prove that both sides of the equation are equal. This is done by transforming the expression on one side of the identity into the expression on the other. To clarify, you can only make changes to one side of the equation. If you change both, you will receive a concept error on a quiz. Do you understand what I'm saying? Okay? So I'm going to give you this problem, and I'm going to say verify. And it's going to have garbage on the left, garbage on the right. And you need to decide, I'm going to work with the garbage on the left to make it look like the garbage on the right. If that's not working for you, you can go back and try work with the garbage on the right until it looks like the garbage on the left. But you can't do a little bit with each until they look the same. Okay? Sometimes that will help you figure out where to go, but you need to go back and make sure that you're only showing me work on one side. And the other thing is, this is about verifying. It's like a proof in geometry. Do you remember when you had to do side angle side and you had to throw in that stupid reflexive step and you were like, oh my gosh, really? We have to? Yes. Okay. This is the same thing. You need to show me a clear set of steps. Don't skip steps. All right. This says, questions show how. That's what's important. Okay. So this is how it started. They decided the left-hand side was really messy, so they should work with that side. Secant squared minus 1 is a Pythagorean identity. It trades for a tangent squared. Then they rewrote tangent squared as sine squared over cosine squared. Secant squared became 1 over cosine squared. Then when you switch to multiply the reciprocal, this one flips over and becomes cosine squared over 1. These cancel and you get a sine squared, which is what we were trying to show. Now, a lot of the trig teachers, and I'm kind of good with this, show that when you get to the bottom, you say this equals to the right-hand side above. I know that's what Miss Gupta does too, her class. So you've done all this. Now you're telling me this equals what was the right-hand side above, okay? Just to show that you're finished and it equals what you were supposed to get it equal to. I used to make students, I was really mean. I'm trying not to be so mean. I used to make students, in college you have to do what's called a therefore. Therefore, I've now proved, and you have to rewrite this step, okay? But that's just time wasted, right? So I'm just going to just somehow tell me you got done. All right, let's try. Which side do you want to try? Left? I'm thinking so because there was no, this looks simpler, right? It doesn't have a subtraction in it. So what do you want to do over here? 1 over cosine minus cosine, okay? Equals. Now what? Common denominator? But you got to show me how you get the common denominator, okay, guys? You can use different colors if you like, or you can write it out. But you need to show me that to make this have a common denominator, I'm going to multiply by cosine over cosine, which is going to give me what? 1 minus cosine squared, and the denominator is just cosine. You can show me that I've combined those now that they have into a single fraction. I'm okay with that. Everybody good? Now what? This is a Pythagorean identity, right? One minus cosine squared is sine squared. Now, this is, if this wasn't a verified question, this is where I'd kind of go, am I done? I always get to this spot and go, am I done? But this is what we're trying to get it equal to. So how can we say that this is equal? If we rewrite this as sine times sine, and it's all over cosine, but does it matter if I just write one of them over cosine? Isn't that equivalent? So then that shows that I've reached the sine times tangent point, which is equal to the right-hand side above. Okay. I can't fit it all on one screen. Do you need me to, I can try to shrink it. Are we good? Sometimes it helps me if I just keep reminding myself where the equal is. Are we okay? All right. Ooh. I don't think I want to work with the left-hand side on this one. What do you think? Do you want to get secant to look like that disaster? I don't think I'd know where to start. So let's work with the right-hand side this time. I'm going to, do you want to distribute first, or do you want to work in the parentheses first? Up to you guys. Distribute? Okay. So sine times tangent plus sine times cotangent. Okay. Now what? Change them into sines and cosines? Is that what you mean by that? Okay. You're good. So what do you want to write for tangent, guys? And back here, cosine over sine. It's good to line everything up, right? So you're making a clear path for Hofbauer to follow how you were changing things as you went. All right, now what? Over here, we can reduce, okay? And on the left, that means we have what? Sine squared over cosine plus just plain cosine. Ideas? Remember, we're trying to get down to secant, which is what? 1 over cosine. Yes? Just thinking ahead here. So we need this to be 1 over cosine. We need a common denominator. What is our common denominator going to tell us to do? Multiply by cosine over cosine here. So that we then get a step that shows what? Sine squared plus cosine squared all over cosine. And then I think we're about done, right? This is a Pythagorean identity. One over cosine, which is secant, which is the left-hand side of there somewhere, right? These aren't on the quiz going to be real short and sweet either, okay? They're going to require some steps like this. Huh? For number 3, oh, we should start with 1. Okay. Actually, I want you guys to do this one. This is all multiplication, so it should be super easy. Yeah, I was going to say, should be like one step, right? Just show it just like that and I'm good. We good? All right. Okay, what do you want me to do with the left side? Okay, so 1 over sine, right, is being divided by cosine over sine plus sine over cosine. Can we just like flip both of these to the top? Normally, if it says like 1 over 4 is being divided by 3 over 5, it becomes multiplied by 5 over 3, right? Can we do that here? No, because it's not got a single denominator, okay? We got to make it a single fraction before we can flip it up to the top. So, you want to just work with the bottom for a second? Okay. So leave this 1 over sine x alone on the top. What do you want to do on the bottom? Get a common denominator? Okay. So this is where I like using some color because then I can skip rewriting it 3 times. This one I got to multiply by what? Cosine over cosine. And this one I got to multiply by sine over sine. So I get what? All over a sine times cosine or cosine times sine. It doesn't matter what order you write it in. It's multiplication. Now things are looking kind of peachy, I think, because what is the top going to become? Okay, this is a Pythagorean identity. So we end up with 1 over sine is being divided by, and I'm going to write it this way this time because I'm going to flip it in a second, 1 over cosine times sine. And then what do I do when it says divide? So I have sine, whoops, 1 over sine times and since it's a multiplication, I can cancel. Sine divided by sine is cosine. Is that what I was supposed to get? Way back up there? I hope so. Yep. I'm going to go back here for just a second. Can I just show you something that we do all the time when we get into higher math? Okay, what is the common denominator for this whole problem right now? Sine times cosine, right? Would be the common denominator, okay? If I multiply the top by sine times cosine, and I multiply the bottom by sine times cosine, okay? When I multiply here, the sine will cancel and I just get what? Cosine, right? On the top. On the bottom, I'm distributing, and I don't want to write it out 10 times, but Sine cosine times cosine over sine, what would happen? If I multiplied this times this, the sines would cancel, and I'd get, okay? If I multiply this times this, sine squared, cosines cancel. The bottom is just 1, isn't it? Okay. This is what's called, the green here was what's called a complex fraction, right? A fraction with the fraction on top and the bottom. If you multiply through by the common denominator of all the fractions, you will always get down to a single fraction and you'll get rid of the complexness. Not a word. All right, just, this is hard for some students to see. That's why I don't usually do them that way. But those of you who get it, it's a great plan. All right. This is looking like get a common denominator, yes? What's the common denominator going to be? Sine y minus 1 times sine y plus 1, which is going to be an identity eventually. Yep. So I guess I got to write this because I got to show my work. So this one's going to get multiplied by a sine y plus 1 over a sine y plus 1. Oh, minus. Oh, we got to be really careful with that. And this one has to be multiplied by a sine y minus 1 over a sine y minus 1. Okay. Well, the denominator is going to have one of each. What happens here? I just get a sine y plus 1. But what happens over here when I distribute that negative? Minus sine y, be careful, plus 1. Okay. Which seems like it might be a good idea because what do I get on the top? A 2, right? And there's a 2 on the right-hand side? Okay. What do I get in the denominator when I FOIL that together? Sine times sine is sine squared of y. Inside would be a plus sine y. Outside would be a minus sine y. 1 times negative 1 is minus 1. Can I skip the step where I add the like terms in the middle? Okay. There's a Pythagorean identity that says sine squared plus cosine squared equals 1. So a sine squared minus a 1 over to this side would equal a what? Negative cosine squared, yes? Okay, so I'm going to use that trade down here. Then what? I'd kind of be okay if you just went directly to the right-hand side because I think most of you get it. But if I move the negative and the 2, what's left? 1 over cosine squared, which is secant squared, which is what we had to get on the right-hand side. Do you need your color? You can't take your folder out there, but do you need your colored unit circle? You got that? And you need one of these guys? Oh, that's fine, I don't care. But do you have your colored, there's one up here if you need it, the renumbered unit circle? Yep. We good? Oh, this looks fun. What do you want to try? Work with the right side? Some of you probably don't even do you all see that this is like an A plus B and a C minus D back here? That there's like a total of 4 terms with pluses and minuses. This one is just messy, right? So I'm thinking we need to FOIL that all together, yes? Okay, so 1 times sine is sine. 1 times negative cosine is negative cosine. Then this gobbledygook times this sine would give me what? Plus sine squared cosine. And back here, the last term times the last term would give me it's all attached, so I have to try to squeeze it in here. This one times this one would be a minus, and it would have a sine and a cosine squared, right? Okay. That's a beautiful thing. Any ideas? I got ideas. I'm just not sure how that would translate for some of you. Do you remember grouping? Wait a minute. That's not the one I want there. I'm going to move this one and this one together. Yeah, I'm thinking this would not be a good quiz question. What do you think? And then I'm going to move these two next to each other somehow. I think I'll put this one first. Doesn't really matter the order. But my thought is, what can I peel out of both of those? If I take that sign out, what will I have? If I take it out of just those two terms. And that's an identity, right? What is it? It's a sine squared, which when we multiply by that sign is going to give us a sine cubed. Okay. Yeah, this is cruel. I would not have put this on a quiz. Okay, what can I take out back here of these two? And what will I have then? Okay. So if sine squared plus cosine squared equals 1, then 1 minus cosine squared is an identity that can trade for a what? You just told me a sine squared. But be careful, what's sine squared minus 1 going to trade for? If you subtract 1 over here, you got to subtract the cosine over here. This is still multiplied though, right? That looks like it says cosine x minus cosine x, but it's a multiplication, so we get what? Oh, that's a squared. Thank you, thank you, thank you. What do we get when we multiply those together? A negative cosine cubed, and on the left side of this right side, we get a sine cubed. Okay. I do hereby solemnly swear that will not be on a quiz. Yeah, the only reason I knew to look for that was because I knew where we were going in the end, that we needed to get some cubes. All right. What do we got? Couple left still? And then it has some calculator stuff. How much time? Oh, we got quite a bit of time. You want to try one on your own? You want to do 8 on your own, or? This one is sine over cosine, right? Plus cosine over 1 plus sine. Yeah. What do you want to do? Common denominator? We could do a conjugate. Yeah, because if we do a conjugate and multiply this by 1 minus sine over 1 minus sine, we're going to get 1 minus sine squared in the denominator, which is a cosine squared, which, well, actually the cosine would then cancel, and then we would be able to have a common denominator. So it's up to you. I'm just trying to think ahead. At some point, we're going to need a common denominator, right? So you want to just do it now? What do we got to multiply this guy by? 1 plus sine over 1 plus sine. And this guy gets multiplied by cosine over cosine. Okay, so up top, I end up with what? Sine plus sine squared, right? Did I do that right? Okay, can I just leave the bottom common for now? Like, I'm not going to distribute it. I don't know if I need to later. But. Okay, what do I get over here? Ah. What happens here? We can add in any order we want. And as long as we leave the plus, we can combine those two, and that's a Pythagorean identity, right? That we'll trade out for a what? 1? So we have a sine theta plus 1 all over a cosine theta times a 1 plus sine theta. I'm a little concerned that if I had, don't write this down, okay? But if I had multiplied the bottom together, if I'd gone ahead and distributed, this would have looked a little confusing, right? Somebody would have done this, and I would have cried. Okay. But because I didn't distribute it, what do you notice? Isn't that whole quantity the same as this whole quantity? So then I can divide it out, right? This divides out with this, and I get what up top? Just a 1. And I'm guessing that's what we were supposed to get, was a secant. How come when they don't look that bad in the beginning, they turn into a nightmare? Well, that one didn't look great in the beginning anyway. Yeah, that one could have been tricky, because if you'd have FOILed it out, you would have had to realize you need to take a cosine out again. And I'm thinking some of you would have just started canceling things out of frustration, right? I know I'm killing kittens, but I don't care. I can't deal with this. All right. What do you want to try here? Magic? Just write meow next to it for me so I know that you knew you were killing kittens. All right. Common denominator? Conjugate? I don't know. Common denominator? Okay. So I'm going to rewrite it. So I'm going to write, what am I multiplying the first one by? Sine over sine. And what am I multiplying the one on the right side of the plus sign? It's still on the side. Roughly 1 plus cosine over 1 plus cosine. Okay, so my new denominator is sine times 1 plus cosine. I know that much. What do I get up top? This is a sine squared. What do I have to do over here, though? FOIL, so I get 1 times 1 plus a cosine plus another cosine, which you can call 2 cosine, plus a cosine squared. Oh, that's beautiful. Now what? Okay, so I'm going to do a little hinky. These two are a Pythagorean identity. And so I have a 1 plus a 1 plus a cosine, which is 2 cosine. Ideas? Somebody's got this. If I simplify the top, I get 2 plus 2 cosine theta all over sine times 1 plus cosine theta. Now, if I look where I'm going, I'm supposed to have 2 cosecant. So the 2 is a good thing. What's cosecant? 1 over sine. So it seems like this 1 plus cosine needs to go bye-bye. How can I make it go bye-bye? If I take a 2 out here, what will I have? 1 plus cosine over sine. I lost a theta there. 1 plus cosine. Now I'm allowed to divide that out. And 2 times 1 over sine is 2 cosecant, which is the right-hand side. How many of you feel like we're just doing magic? All I can tell you is try, bring it in, let me help you see where you're stuck. Erase, try something different. Take a peek at the answer key if you have to, but don't just copy it or you'll learn nothing. All right, everybody good? All right, this verifying section says use a graphing calculator to test whether this is an identity. What you're supposed to be doing is just, where's my little, move. There's my wabbit under there somewhere. Okay, how do I graph? First of all, what mode do I need to be in? Radians. I'm going to make sure I don't have anything in my y equal. How do I type this left-hand side? Not second sine. 1 divided by sine x, closing my parenthesis around the x, minus sine x. And I could put parentheses around the whole 1 minus sine x, put an extra set. Or, I'm sorry, around the whole 1 divided by sine x. But it always divides before subtracts, right? So I'm okay. All right, how do I do this side? Okay, 1 divided by tangent of x, closing the tangent of x parenthesis, and then times cosine of x. Is the calculator going to do that right without extra parentheses? It's going to divide first and then multiply, right? Because left to right. So it's okay. You can put extra parentheses if you want, but we're good. If you put an extra parenthesis a left, you got to know where to close it. All right. I'm going to try a zoom trig, see what happens. trying to see if these are equivalent. Okay, I'm watching the first one graph. Now my little wiggly worm is still going, but I don't see anything. Why is that? The little thing in the corner. It's probably overlapping. Does anybody remember how we can turn that on and check? If you have a color calculator, it's a beautiful thing, right? It changes from red to blue right over the top. If you have an old calculator, you can go to the left on the second one and hit enter once and it'll do bold. So then what'll happen is the first one will graph, and then the second one will come in and graph in bold, and you'll see it go right over the top. Does that make sense? The other thing you can do, if you hit enter a couple more times, you get the little round circle. You can watch it trace right over the top. Lots of things you can do. But so is this one an identity? Yes. Oh, it says verify it. I'm just going to go with yes. Is that okay? All right. Oh, here's one we're supposed to do in our calculator. All right. Sine x, close parenthesis, plus cosine times cotangent would be cosine of x, close parenthesis, times 1 divided by tangent. I put a parenthesis in front of that. All right, and then it says equals cosecant, which is just 1 divided by sine. This time I'm going to arrow to the left, and instead of turning on the bold, maybe I'll turn on the bouncy ball, which is that little guy. They may not be identity anyway. Here's the first one coming through. Here's the second one. Oh, and it is tracing. Tracing. So this one is also an identity? Somebody else getting that to be a yes? Yeah. Okay. This one you would have to type in like this, okay? On your calculator, it will actually work if you type 2 minus cosine of x and just put the squared out here. And y2, you type sine of x, just put the squared out there. What do you think? Do you think that's going to be the same? No, because if 1 minus cosine squared is sine squared, right? So this is going to be a no, doesn't work. What it says is find a value of x for which it's not equal. I didn't put any of these on the quiz anyway, but there's, I think, one on the homework or two where you have to, it's always good to be able to type it in. All right, these are the problems you need. Again, 5152 bookwork is here if you didn't get a copy yesterday, okay? 9 problems, okay? Try them and see where you get stuck.